Welcome to this explainer on the ARGUS proposal. Today we're looking at a wildly ambitious 2026 project coming out of Italy's National Institute for Nuclear Physics, or IFNN. They're aiming to completely revolutionize how we operate massive, deeply complex scientific facilities using artificial intelligence. We're talking about taking the incredibly fragmented data of particle accelerators and turning it all into one unified, intelligent brain.
Let's kick things off with the central question that plagues particle accelerator operators literally every single day. Imagine sitting in a control room. You've got thousands of operational signals flashing at you. But to actually figure out what went wrong, you have to dig through fragmented technical manuals, standard operating procedures, electronic logbooks, and maybe even rely on the tacit, unwritten knowledge of a senior expert who just happens to be on a 2-week vacation in the Alps. It is a wildly frustrating reality.
Over the next few minutes, we'll map out this journey from information overload to a unified AI future. We're going to cover the fragmented knowledge problem, introduce ARGUS, look at AI agents in the loop, explore administrative AI, touch on data sovereignty, and wrap up with the interdisciplinary future. Starting out with part 1, the fragmented knowledge problem, or what we can call the nightmare of scattered information.
Traditionally, diagnosing a fault means navigating these incredibly frustrating silos of information, but the proposed ARGUS knowledge layer aims to shatter those silos entirely. It creates a unified semantic substrate, essentially making every single piece of facility data instantly queryable.
And what's really fascinating here is the sheer variety in this heterogeneous data diet that ARGUS is going to digest. We aren't just feeding a few PDF manuals into an AI and calling it a day. No. We're talking about a continuous pipeline harvesting live hardware data from Epic's control systems, device databases, daily electronic logbooks, and, crucially, even searching for information across scientific publications and extensive patent databases. ARGUS is specifically designed to eat all of this wildly heterogeneous knowledge in real time.
So how do you actually process all of that? Well, let's jump to part 2 and meet ARGUS, the AI native knowledge operating system. The absolute crucial point to understand is that ARGUS is not just a simple bolt-on chatbot. It's defined as a comprehensive AI-native knowledge operating system. It really acts as the facility's unified brain. It takes all that unstructured data we just talked about, marries it with live data streams from the accelerator, and maps it all onto a structured knowledge graph to ground the language model in absolute reality. And grounding is everything here. By combining semantic document search with that structured knowledge graph, which maps out the actual physical relationships between devices, alarms, and procedures, ARGUS targets a massive 50% reduction in fabricated or unsupported AI answers. When you're running a multi-million-dollar particle accelerator, you literally cannot afford AI hallucinations. This hybrid retrieval system ensures every single answer comes with a fully traceable citation.
Moving on to part 3, we're taking things from passive search to active support with AI agents in the loop. ARGUS actually goes way beyond just answering questions by unlocking incredible agentic possibilities for managing these machines. It can theoretically tune beams or optimize parameters, but it's strictly governed by a 4-step human-in-the-loop safety mechanism. First, the AI synthesizes a recommendation based on live data. Second, it presents this decision support to the operator. Third, a human must confirm the action. And fourth, it executes the action on the control system with a full audit trail. So the AI never takes rogue actions on the hardware without a human holding the keys. This agentic capability allows operators to use natural language to actively troubleshoot incredibly complex scientific infrastructure. Let's say the beamline physics software throws an obscure error. ARGUS will cross-reference that live error with years of issue tracking histories and expert records, essentially serving as a senior diagnostic partner sitting right there with you in the control room.
Now let's look at part 4, administrative AI, and how this scales way beyond the accelerator itself.
The true brilliance of the ARGUS architecture is that this unified knowledge layer isn't restricted purely to physics. Because, let's face it, managing these facilities requires a massive administrative backbone too. The exact same AI architecture bridges both worlds. So the hybrid retrieval system used to tune a particle beam is equally capable of helping central administration streamline HR workflows, manage complex hardware asset inventories, or assist with IT onboarding. It proves that managing heterogeneous knowledge is universally valuable across the entire organization.
But of course, this brings us to part 5, the data sovereignty mandate, keeping sensitive secrets safe. Handing over your facility's entire operational memory to an AI brings up a massive, unavoidable concern, and that is security. The proposal is explicitly clear on this. They state that cloud-based language model services flat out conflict with the Institute's data sovereignty and security policies. You just can't hook up a national nuclear physics lab to a commercial public cloud AI provider and cross your fingers. This is all driven by the concept of data sovereignty. Basically, it's the strict requirement that digital data remains subject to the direct governance of the organization that collected it. For INFN, piping sensitive maintenance records, undocumented software vulnerabilities, or internal administrative data out to some external server, total non-starter.
So how do they get around this? With serious on-premise hardware. ARGUS is designed to run entirely inside the laboratory's walls. They're asking for a dedicated AME server packed with 4 advanced NVIDIA H100 GPUs, and it's all locked down within secure, confidential containers at the Frascati National Laboratory Data Center. This physically guarantees that no sensitive incident report, whether it's an accelerator fault or a routine IT security patch, ever leaks out to the wider internet.
Which brings us to our final section, Part 6, an interdisciplinary AI future, serving as a blueprint for Europe.
Bringing a project of this magnitude to life demands a deeply interdisciplinary team. Just look at the resource allocation here. You've got the Frascati Lab bringing accelerator controls and AI infrastructure. You have the Legnaro Lab bringing specialized expertise in machine learning for exotic radioactive ion beams. Then you have central administration handling IT and administrative use cases, and LASA handling complex asset inventories. It's an incredible blending of physics, central IT, and high-performance computing. And by proving this secure, reproducible model works across multiple Italian labs and totally different disciplines, ARGUS is positioning itself as way more than just a localized tool. Because it aligns so perfectly with the stringent EU AI Act and CERN's trustworthy AI strategy, it's effectively serving as a foundational AI blueprint for all European scientific infrastructures going forward.
As we wrap up this explainer, we really have to zoom out and look at the big picture. If ARGUS succeeds in safely uniting the fragmented knowledge of a particle accelerator using highly secure, on-premise AI agents, you've got to wonder, will this interdisciplinary blueprint for trustworthy, sovereign AI become the ultimate key to managing all of human civilization's most complex critical infrastructures? It is absolutely a project worth keeping a close eye on.